Motion in vertebrates, animals with bony skeletons, is accomplished through movement at joints holding bones together. This is primarily rotation with minor elements of gliding and twisting. The armature and bone segments in Blender's rigging is meant to mimic this movement. This rotation in life comes through changes in muscle contraction and relaxation. This is transmitted via tendons attached to the bones and accompanied by movements in ligaments, joint capsules, and skin. In Blender, these changes can, in part, be accomplished through parenting, hook modifiers, and shrink wrap modifiers. However, structural changes in mesh will inevitably become necessary. A model of the long finger ray from a human hand is presented for demonstration. This model includes the metacarpal, proximal, middle, and distal phalangeal bones. Flexor tendons bend the finger. Extensor tendons straighten the finger. Small muscles attached to the metacarpal assist these actions. Joint capsules hold the bones together. Bending of the joints is accompanied by movement in the long tendons and contraction/relaxation in the small intrinsic muscles. This change in mesh geometry is accomplished with shape keys. The lower small muscle is called a lumbrical, Latin for worm. It is attached to one of the long flexor tendons and must move with it. It also contracts or shortens when the two distal joints are straightened. Note the lack of lumbrical motion without shape keys. Shape keys bring the muscle to life. The lumbrical is selected in object mode with a right mouse click. The shape keys controls lies in the Object Data Properties tab, green triangle, third from the bottom, and the Data Properties window. Shape keys is second from the top. Clicking on the plus key gives you a basis and additional keys. The basis is your starting geometry. You can rename any other keys. Left mouse click your shape key and a new menu will open. Set the value at maximum, usually 1.0. Bend all joints to get maximal tendon movement. Left mouse click the lumbrical. Tab key to edit mode. Select all vertices with the A key. Move with G keys along the Y, Z axis. Tab key to object mode. Any edits in geometry will be represented in the selected key at a value of 1.0. A value of 0 will return lumbrical to the basis geometry. You can set frames in value field to match specific rotations in the timeline. However, as an example, the rotation in the second joint alone of this model is linked to over 24 separate meshes. Doing these changes manually as keyframes would be exhausting. We can automate the geometry change with joint rotation using a driver. Right mouse click the value key and the shape keys are submenu. Left mouse click add driver and value pop-up menu. A driver's property menu will pop up. If you move your mouse from this window, it will disappear. Right mouse click the values tab and this time select the open drivers editor. This window will remain open until you exit out. You may need to use the N key to get the right side panel. In this, you will see a drivers tab. There are several driver types. Normally, we'll use the scripted expression in these situations. The expression var plus 0.0 will be present. Leave as is for now. Next we will input variables. We can add as many as we like. Each variable will be assigned a new name. These can be changed. Next to the variable name is the variable type. The two variable types applicable to our situation is the transform channel and rotational difference. Rotational difference will use rotational difference between two objects in any plane. Transform channel allows you to specify the plane of rotation. This is very useful when different plane rotations are used to drive different shape keys in the same mesh. The transform channel will ignore rotations caused by rotation in a parent of the driver object. As a general rule, we will stick to the transform channel. Change world space to local space. Select the objects that will drive our shape keys for each variable. Our expression will use the sum of the three variables. To allow for the different sizes in this joint, we will multiply MP by 0.5, PIP by 0.3, and DIP by 0.2. My maximum rotations will be 70 degrees at the first joint, MP, 95 degrees at the second, PIP, and 85 degrees at the third, DIP. If we run our animation, a problem becomes evident: no lumbrical movement. This is because all our rotation are negative. We add a negative in front of our expression and run our animation again. We still have a problem. The lumbrical moves, but it does not match the tendon movement, and its final position is way too early in the rotation and just hangs there. Back to the driver editor. Set all rotations to maximum. Our driver value is 1.405, but in the value window of our shape keys menu, the value only goes to 1.000. What gives? Let's look back at the driver editor window. Look at the value at the bottom of each variable window. MP is minus 1.222, open paren, minus 70.0 degrees, close paren. Blender lets you use degrees in the user interface, but deeper down it is using radians to measure rotation. It is normally converting for you on the fly, but in drivers and geometry nodes it uses radians. The value notations are there to remind you. Okay, what the heck is a radian? Degrees are an arbitrary measure of angles handed down by the Babylonians and Egyptians. Instead of 360 degrees in a circle, it could have been 100 degrees or 800 degrees, doesn't matter. A radian is an arc length equal to the radius of the circle. Its angle is derived from the arc formed by an angle. Trigonometry functions are calculated using radians through the use of special polynomials called Taylor series. Blender is a computer program controlled by its code, Python to be precise. At its heart, Blender is math. Degrees have to be converted into something real. 1 radian is equal to approximately 57.29 degrees, specifically pi divided by 180. In the Shape Keys menu, the value is from 0.000 to 1.000. This can be thought of as a percentage morph or change for the basis geometry to the new shape key geometry. 0, no change. 1, 100% change. Blender has to have some way of linking this to changes in the driver. It looks for 0 to 1 radians for a 1 to 1 correlation. So, what now? Divide the expression in the driver editor window by the driver value, in this case 1.405. Zero rotation is still 0 radians, but full rotation is now 1 radian. Now full rotation gives us 100% geometry change at the right time. As is common with Blender, you can get this result several different ways. We could increase the maximal value of the shape key to 1.405. And the driver's editor expression, you could divide each variable by its maximal value in degrees and convert to radians by multiplying by pi divided by 180 or 57.29. However, dividing by the driver value is the simplest, most foolproof method. Step 2. We also need the lumbrical to contract or shorten with straightening of the last 2 joints. Select Armature, Control-Tab to Poser mode, and set angles for bones. Control-Tab to Object Mode, select the lumbrical. Right mouse click over driver value and add a new driver. Set value to 1.000, tab to editor window, and adjust geometry. Right mouse click over driver value and open driver editor window. The lumbrical must be selected in the object mode window. Add a new variable and name variables if desired. Change each variable type to transform channel, X rotation, and local space. Select armature and appropriate bones for each variable. Enter expression. Don't forget the minus sign if indicated. divided by the driver value. With rotational drivers, Blender looks for 0 to 1 radians of movement. Anything under 0, negative rotation, and anything over 1 is ignored. As a side note, if you look at the transform nodes in the object mode, you will notice a control underneath rotation channels. This is normally set to XYZ Euler. Other options include changing the Euler axis, using axis angle, or quaternions. These are 3D rotational systems that Blender actually used to handle rotation. If you use armatures for your rotation, Blender uses quaternions by default. This alone is a good reason to use armatures. There is good argument to always use quaternions. Degrees and radians are for us mere mortals. I initially found working with rotational drivers for shape keys very frustrating and online help limited. I hope you find this information enlightening. Thank you for your time, and thank you for your attention.